In this video, we are going to look at one of the project scheduling techniques, that is critical path method network diagram. In this example, we have 8 activities A through H. Each activity's predecessors are given and then the duration of each activity is given. Let's first start with drawing a rough draft so that we can better understand how our precedence or network diagram is going to be looking like. Here, activity A does not have any predecessors, so we know that activity is starting first. Activities B and C both have common predecessor, that is activity A. So once activity A is completed, we know activities B and C are going to start. For activity D, the predecessor of activity D is B. So once activity B is completed, activity D is going to start. Similarly, for activity E, the predecessor is C. So once activity C is completed, activity E is going to start. For activity F to start, its predecessor activity D has to be completed, and to start activity G, it has two predecessors, activity B and E. So both activities B and E needs to be completed to start activity G. Similarly, for activity H, the predecessors are F and G. So to start activity H, both activities F and G needs to be completed. So this is how our network diagram is going to look like. In this precedence diagram, I'm going to use this format where the top is going to represent the activity, ES, early start, early finish, late start, late finish, duration, total float, and then free float. Each of these terms will be clear once we proceed with the example. Now let's start drawing the precedence diagram. We know that activity A is going to start first. Once the activity A is completed, activity B and activity C are going to start. Once activity B is completed, activity D will start. Similarly, once activity C is completed, activity E is starting. For activity F to start, activity D will have to be completed, and the successors of activity B and E is activity G. And once activities F and G are completed, activity H will start. Let's look at the forward pass. By performing the forward pass, we will be getting the earliest schedule or optimistic time of our project, that is the earliest schedule that each activities can gain throughout the project duration. We are going to look at two terms, early start and early finish. The early start is the earliest time an activity can begin, and early finish is the earliest time an activity can finish. So let's start with activity A. Since it does not have any predecessor, it will start at day 0, that is end of day 0, and it has duration of 2 days. So its early start is going to be 0 with duration 2, and its early finish will, for any activity, will always be equal to early start plus the duration of that activity. So the early finish of A would be 2 days. Now once activity A is completed at the end of day 2, both activities B and C can be started at the end of day 2. So early start of both activities B and C will be 2 and 2. The duration of activity B is 3 days and activity C is 5 days. So the early finish of activity B is going to be 2 plus 3, end of 5 days, and activity C will have early finish of 2 plus 5, 7. Similarly, duration of activity D is 4 and duration of activity E is 6. For activity E to start, once the activity C is completed at the end of day 7, activity E can be started. So early start is 7, early finish for activity E is going to be 7 plus 6, 13. Similarly, D has only one predecessor, B. It ends at end of day 5. So activity D can start early at end of day 5 and then finish early at the end of 5 plus 4, that is 9. Now for activity G, it has two predecessors, activity B and activity E. So both of these activities need to be completed to start activity G. Can the early start of G be 5? So at the end of day 5, activity E will not have been completed, right? So the early start of activity G should be 13. So we can see that early start of any activity should be equal to the maximum of early start, this should be early finish of the predecessor. So the early start of the activity G should be maximum of the early finish of B and E, that is 5 and 13, which is 13. And then the duration of activity G is 4 days, so early finish for activity G would be 17. Similarly, for activity F, it has only one predecessor, so early finish is 9. Early start of F will be 9. The duration is 2 days, so early finish would be 11 days. And similarly, the same case here for activity H. Once both activities F and G is completed, activity H can be started. So maximum of early finish of predecessors of activity H is maximum of 11 and 17, which is 17. Now duration of activity H is 2, so 17 plus 2, early finish of activity H would be 19. Now let's look at the backward pass. By performing the backward pass, we can actually look at the latest schedule of each activities. In backward pass, we start from the last activity we have and then progress towards the first activity. So now we know that the total project completion days would be 19 days. So the latest or late finish of activity H would be 19 days. Here late finish is the latest time that activity can finish without delaying the project, and late start is always late finish of that activity minus duration. So the late start for activity H is going to be 19 minus 2, 17. Now activity H has two predecessors, F and G. Since both activities have only one successor, the late finish of both activities is going to be late start of the predecessors, right? 17 here, 17 here. So late start of activity F is going to be 17 minus 2, 15. Late start of activity G is going to be 17 minus 4, that is 13. For activity D, late finish is going to be the late start of its successor activity F, which is 15. For activity E, the late finish is going to be late start of activity G, which is 13. And then late start of activity D is 15 minus 4, 11. Late start of activity E is 13 minus 6, 7. Now for activity B, we need to be careful here the late start and late finish, right? So the late finish for any activity such as activity B, which has two successors activities D and G, will be the minimum of late start of successor. That is, the latest time that B can finish would be minimum of 11 and 13, that is 11. So let's start for activity B is going to be 11 minus 3, that is 8. And then for activity C, it only has one successor, so late start of activity E is going to be late finish of activity C. And then 7 minus 5, that is 2. Now similarly for activity A, the late finish is going to be minimum of 8 and 2, that is 2. And then late start is going to be 2 minus 2, which is 0. Let's look at the total float. The total float in project schedule is the amount of time any activity can be delayed without delaying the completion of the whole project. So the total float we call like TF is calculated as either late start minus early start or late finish minus early finish. So in this case, for activity A, total float is going to be 0 minus 0, which is 0, or 2 minus 2 is 0. Similarly for B, 8 minus 2 is 6, 11 minus 5 6. For C, 2 minus 2 is going to be 0, 7 minus 7 0. For D, 11 minus 5 is 6. For E, 0. For F, 15 minus 9 6. For G, 13 minus 13, 0. For H, 17 minus 17 or 19 minus 19, it's going to be 0. So what does that mean? Since total float of activity A is 0, it cannot be delayed by any days. So let's say if activity delayed by 1 starts at day 1, here its ended would be 3. Here the C would start at day 3, and then it would go 8. Here 8 plus 6 would be 14. 14 plus 4, 18. And then this would be 18, and then the end date of project H would be 18 plus 2, which is 20. So whole project is going to be delayed by 1 day. Similarly here, like let's look at project E. Total float is 0 as well, but if it is delayed by 1 day, then it's going to be started at day 8. Same case, right? Day 8, 6, 14. Here the early start would be maximum of this, so this would be 14, and then whole project is going to be delayed. However, if you look at activity, for example activity B, which has total float of 6, that means it can be delayed by 6 days. Let's delay it by, for example, 2 days. It starts at, instead of day 2, starts at day 4, then it finishes at day 4 plus 3, 7, right? And then here it does not affect the starting day of activity G, because activity E finishes at day 13, so its early start is going to be day 13. However, this 7 would carry over to activity D, so activity D will be delayed by 2 days as well, and then it finishes at 7 plus 4, 11. Similarly, activity F would delay by 2 days as well. It will start at day 11, end of day 11, and then finishes at end of day 13, right? However, to start activity H, both activities F and G should be completed, so its start date will still be the end of day 17. So this is not affecting any total schedule. 17 remains the same, and then the end date of the whole project will be 19. Same case, even if you change this or delay this by 6 days, it's not going to affect the whole project schedule. Now let's look at the free float. Free float in project scheduling is the amount of time any activity may be delayed without delaying the early start of next activity. So we have to be really careful here, because it is different from total float. Although it is a slack or float, it is different from total float, because total float is the amount of time any activity may be delayed without delaying the whole project completion. But free float is the amount of time any activity can be delayed without delaying the early start of its successor or its next activity. So free float is usually calculated by this formula, that is minimum of early start of the successor activity minus early finish of that activity. That is, so free float for activity A is going to be minimum of the early start of activity B and C, that is 2, minus the early finish of that activity, that is 2 as well, so it's going to be 0. Similarly, free float for activity B, it is going to be, its successor is D, so its early start for successor is 5 minus early finish 5, 0. For activity C, free float is going to be early start of E, that is 7, minus early finish of C, that is 7 as well, that is 0. For activity D, it is going to be 9 minus 9 again, that is 0. For activity E, it's going to be 13 minus 13, that is 0. And for activity F, it's going to be 17 minus 11, that is 6. And for activity G, it's going to be 17 minus 17, that is 0. So free float is, again, it's the amount of time an activity may be delayed without delaying the early start of next activity. Let's look at activity B. It has free float of 0. it cannot be delayed, because if we delay this activity by 1 day, it is going to delay the early start of next activity, right? So if we delay this by 1 day, let's say instead of end of day 2 it starts at end of day 3, then its early finish is going to be 3 plus 3 is 6, and then the early start of activity D is going to be day 6 as well. So it impacts the early start of the successor. However, if you look at example activity F, it has free float of 6 days. That means it can be delayed up to 6 days and still it is not going to affect the early start of the next activity H. If instead of day 9 it starts at, let's say it got affected by day 3 days, then it starts at end of day 12, then it is going to end at 12 plus 2, that is 14, right? End of day 14. However, activity H can only start after completing both activities F and G, right? So activity G cannot complete until end of day 17. So early start for activity H will be day 17. This is not affecting the early start, so it has the free float of 6 days. So instead of 6 days, let's say this activity F is delayed by 7 days, then what's the start day? It's going to be 16, and then finish day of the activity F is going to be 16 plus 2, 18. So now we know that activity F only has free float of 6 days, but then this activity got delayed by 7 days. Then its finish day is the end of day 18. So this is going to affect the early start of H. That means the free float of 6 means that the activity F can be delayed by 6 days without affecting the early start of the next activity H. If this activity gets delayed beyond that free float, then it's going to affect the early start of the next activity. Finally, it is very important to find the critical path during project scheduling. The critical path is the series of the interconnected activities through the network where each activity has 0 free float and 0 total float. So if any activity on the critical path is delayed, the project is going to be delayed. So in our case, activity A has both total float and free float 0. And then activity C, E, G, and H. So our critical path is going to be A to C, C to E, E to G, and then G to H. This is our critical path. So if any activity A, C, E, G, or H gets delayed, then the whole project is going to be delayed. That's why it is called critical. So that's it for this video. I hope you understood what critical path method is, what activities are, how to draw the network diagram, what early start, early finish, late start, late finish are, what is critical path, and then how to calculate the float. If you have any confusions or any questions, feel free to drop it down in the comments below, and do not forget to like and subscribe. Thank you.